Could the bacteria living in your dog's mouth be affecting their brain? It sounds unbelievable, but the science is becoming increasingly difficult to ignore. For years, we thought periodontal disease was just about bad breath and loose teeth. Today, we're learning it may be a chronic inflammatory disease capable of influencing the entire body, including the brain. And what's fascinating is that dogs and humans appear to share many of the same pathways. Let's start with the aging brain. Both people with Alzheimer's disease and dogs with canine cognitive dysfunction syndrome develop chronic neuroinflammation. The brain's immune cells, called microglia, they normally protect neurons by clearing debris and repairing damage in the brain. But with age, those microglia can become chronically activated. And instead of turning inflammation on and then shutting it off, they remain stuck in an inflammatory state. And that persistent inflammation damages synapses, it disrupts communications between neurons, and eventually it contributes to cognitive decline. So where does the mouth come into this? Periodontal disease is one of the most, if not the most, chronic inflammatory disease in both dogs and humans. The bacteria don't just stay on the teeth. Every time inflamed gums bleed, even microscopically, bacteria, bacterial toxins, DNA fragments, and inflammatory molecules enter the bloodstream. Think of severe periodontal disease as a slow daily leak of inflammatory signals into the circulation. Now, the immune system stays activated, not for hours, but for years. This chronic systemic inflammation may prime the microglia. So instead of resting quietly, they become more reactive. So then when amyloid proteins begin accumulating in the aging brain, those already primed microglia, they can't mount an exaggerated inflammatory response. It's like pouring gasoline onto a fire that had only just started. Even more interesting, researchers have identified DNA from periodontal pathogens, bacteria, including Porphyromonas gingivalis, within the brain of some people with Alzheimer's disease. Its toxic enzymes called gingipanes have also been detected in affected brain tissue. This doesn't prove that bacteria cause Alzheimer's disease, but it strongly suggests that they may contribute to disease progression. Dogs don't develop Alzheimer's exactly the same way humans do, but dogs do accumulate amyloid beta. They develop activated microglia, reactive astrocytes, blood-brain barrier dysfunction, and oxidative stress and cognitive decline. However, dogs actually generally develop much less of the tau pathology than humans do. But that's why canine cognitive dysfunction is considered a naturally occurring model of early Alzheimer's, not an identical disease. Now, here's where veterinary medicine gets exciting. Dogs develop periodontal disease naturally. We know that 80 to 90% of dogs by the age of 3 have periodontal disease. They share our homes, they share many of the environmental exposures, and they age much faster than we do. That makes them an incredible model for studying how chronic oral inflammation affects the aging brain. In fact, periodontal disease may contribute to cognitive decline through several mechanisms that happen simultaneously. Chronic systemic inflammation, the priming of microglia, increased blood-brain barrier dysfunction, oxidative stress, reduced clearance of amyloid proteins, and possibly even direct effects of bacterial toxins reaching the brain. Now, this doesn't mean brushing your dog's teeth will prevent dementia. We simply don't have that evidence yet. But what we do know is that periodontal disease is one of the few chronic inflammatory diseases that we can actually prevent and treat. And reducing inflammation almost always benefits overall health. So maybe oral health isn't just about saving the teeth. Maybe it's one of the ways that we can protect the aging dog brain. The mouth and the brain may be far more connected than we ever imagined. Follow me for more evidence-based veterinary medicine.